Hi, I'm Sanskar, and this is our introduction to Android development. In today's video, we'll first look at Kotlin, its need and usage, some basic syntax, as well as the execution environments. Then we'll move on to Android, introducing the way to build Android apps by using Android Studio and a very simple Android app, how the code looks, how it's structured, and so on. Let's start with Kotlin. Why do we need Kotlin? Why do we not use Java anymore? So the first major reason is that Kotlin is much more modern. Java came out in 1990s and hence the syntax is a bit verbose and dated. This is a sample program that just prints hello world to the console using Java. We first have to declare a class, then use several keywords to define a main method, and then use system.out.println just to make a simple console output. With Kotlin, things are much simpler. We can just say fun main and then print line what we need to. Kotlin makes it easier to write and understand code, reduces the verbosity, and increases developer productivity. Another thing is that Kotlin is fully interoperable with Java. What this means is that we can call Kotlin code from Java and Java code from Kotlin without maybe having to use any bridges or to have to make any changes. That means that we can use all the existing Java ecosystem with Kotlin, including the libraries, frameworks, and everything that has been developed over the past years without us having to build any special utilities to make the interoperability work. The next big thing is null safety. Most of Java's exceptions or the Android app crashes that we see come from null safety or null pointer exception. So with null pointer exception, what happens is that the system is looking for some data that is not there. Is instead of hello, we actually have null. With Kotlin, this nullability and the null safety itself is built inside the language. So we don't have to make checks and we can use the safe nullable operator to make our calls without us having to worry about running into any nullability exceptions and our applications crashing. The next big thing is asynchrony, which is built into Kotlin. So asynchrony is a bit of an advanced topic, but what happens with UI applications is that there is typically only one thread which is used to make the UI visible on the screen. So if you need to make any database or network calls, get some data from an API, or perhaps get some data stored on the user phone, then it might take a while, and until then your UI cannot be displayed. This can lead to app not responding exceptions and poor performance overall. That's why we use asynchrony. With Java, we have concepts like live data, RxJava, etc. But with Kotlin, the asynchrony is built into the language itself, and we can basically create it using suspend functions. Suspend functions and coroutines allow us to easily build asynchronous application without having to worry or use an external library like RxJava. Now, let's talk about how much Kotlin is used in the industry. So, looking at some stats, more than 70% apps on Play Store use Kotlin in some capacity. This is representative of the top 1000 apps that people download. 96% of the new Android projects are started using Kotlin, and Java is used in very few projects where the developers are even not familiar with Kotlin or they have some specific use case which Kotlin cannot fulfill, which is very rare in most cases. It is the sixth most wanted language according to Stack Overflow Developer Survey. That means developers want to work with Kotlin a lot. Let's talk about execution environment. What we mean by that is that Kotlin can be compiled to any number of platforms or targets. It can be easily compiled to JVM, on which the Android ecosystem is based. So that basically runs the Java bytecode and it is 100% interoperable with Java, so we can easily use Kotlin anywhere we can use Java. It can also compile directly to native binaries like what C, C++, or Rust produce, so it can be run on iOS, macOS, or any desktop system like Linux or Windows as well. And it can also compile to JavaScript, or rather transpile to JavaScript through the Kotlin JS extension. One interesting thing that is coming up with Kotlin is the multi-platform capabilities. That means we can maintain one Kotlin code bases for targeting multiple platforms, quite a bit like Flutter. For our learning purposes, we'll use the Kotlin Playground, which is basically an online execution environment where we can type and run our Kotlin code. Now let's look at some Kotlin syntax. Kotlin is a simple programming language. It's functional, it's object oriented, and lets the programmer build very powerful applications while having to write much less code than other contemporary languages like Java. This is a simple Kotlin program where we basically execute a number guessing game. So in this game, we generate a random number and the user gets 3 tries to guess that number. Every time the user guesses that number, we let the user know whether their number is too big, too small, or if they have found the correct number, in which case we terminate the program. So let's look at the first line. Import kotlin.random.random. This basically says that we need the random function, which we are using right here. Then we have function main. So function main is the entry point of any program. As soon as you execute a Kotlin program, what the first thing that the system will do is look for the main function and execute it. Now, we are using a val. Val is basically used to declare values. These are immutable and cannot be changed later on in the program. Think of it as a box where you can store some values and they will be available for the rest of the program for your usage. So now we are generating a simple random number between 0 to 100 using the nextInt function. Then we are repeating this entire code block a total of 3 times. Every time we do the same operation. That is, first of all, we print input your guess to the user. Then the user reads that message and inputs the guess number. Then we let the user know that we are trying their input to see whether it matches with the original number or not. Then we are introducing a when statement. A when statement is sort of like a conditional statement. So it lets us check whether if certain conditions are met, then that code block will be executed. So let's say the user's input is greater than what our program initially generated as the guess number. In that case, we let the user know that the number they have guessed is too big. Then we check whether the input is less than guess, in which case we let the user know that the number is too small. But if input is equal to the guess, then that's a match. We let the user know that they have obtained the right number and execute a return statement. Return statement basically cancels out the whole program. It returns from the main function, hence the program terminates. Now at the end of it, we have added a statement you lost. Now how do we say that? Because if the program hasn't returned by this point, then the user has gotten here. That means the program tells the user you have lost. If the user had already won, that is, they got a match, the program would simply return, cancelling the execution before it even gets here. Since execution is sequential, that means lines of code are executed one by one. Now, let's look at some basic Kotlin types. So, types are basically a description of what kind of data the variable or the property will hold. So, we have two declaration types. So, well, first one we have val. So vals, once defined value cannot be changed. That means if we say val something is equal to 10, then we cannot say something equal to 15 later on. That value is immutable, meaning it cannot be changed. Then we also have var, which stands for a variable. It basically represents values that can be changed during our program's run. So let's say if we have something like var x is equal to 10, and we later say x is equal to 15, and that works. What cannot be changed though is the type of the value. Let's say we have a variable which is of type string. Then we cannot input an integer in it. So our syntax to do that is first we write either val or var depending on whether we want our value to be changeable or not. Then we input a variable name. This variable name should represent what kind of data it's holding. Then we can declare a type which is optional. The type is optional because the compiler can understand what type of data we are assigning to the variable or our val. Then we can use the equal to sign to provide it an initial value. Let's look at an example. If we write something like val location string equals California, then in that case, we are first saying that we want an immutable value, that is, location once defined cannot be changed. Then we specify the type to be a string, and then we initialize that val with the value California. Otherwise, we can omit this string definition since the compiler can itself infer that this is a string. This is called type inference. Below us is a number of examples that we can see. So this is a simple Boolean type. It can either be true or false. This is an integer type, which can be an integer, so that would be a whole number like 10, minus 15, or 25. It has a ceiling of 2.1 billion. Then we have a float where we can define fractional values, but with less precision. And then we have a double where we can define fractional values with more precision. Then we have the character types where we can just define a single character like just A or Z or a plus symbol. Then we have strings, which are a collection of characters. So we have multiple characters in a row, like something has 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. So this is a string. And then finally we have lists. Lists can be defined by the list of operator, and they basically hold data of same type but with multiple instances. So something like 1, 2, 3, 4, 5 is that's a row of numbers that can be represented as a list. That was Kotlin's basic types. Now we'll talk about the control flow. The control flow is basically responsible for diverting a program's execution or modifying it a little bit. As we know, every program executes sequentially, that is, lines of code are executed one after the other. So if we want to change that a bit, maybe repeat the code block sometimes or not execute a code block depending on a condition, we can use a control flow statement. So let's first look at the most basic statements, which are if, else, and when. So if else is used to check a condition to be true or false. If the condition is true, then the if block is executed. Otherwise, if it's false, then the else block is executed. We also have the when operator with Kotlin, which can be used when we need to check multiple conditions at once. Let's first look at an example of if. So with if, we have something like this. We have a couple of values, and we can check if A is greater than B, then we can print A is bigger, else we can print B is bigger. We can chain if-else statements to form very large conditional checks, and these are very heavily used while programming. Then we also have the when statement, where we can check whether the value is something or other for multiple possible values. If else only allows us to check one condition at a time, while when allows us to check as many conditions as we want at a time. Now, one thing to note is that expressions, so basically if and else and when, return expression types in Kotlin. So we can use them to basically evaluate a value or something like that. So now we have declared a value called A, which is 15. Then we can check when the A value, which we have specified here, is 1, then we can say it is 1. If it's not 1, if it's 2, we can say it is 2. Or if it's not either of these, then we can say else case it is greater than 2. This result is returned by when and saved into this val result. Then later on we print this val result at the bottom of our program. The next major blocks are for and while loops. For loops are used to repeat a code block a finite number of times. Typically in advance we know like we want to iterate over this array which has the size of 10, or we want to iterate over this string which has 8 characters. While loop basically lets us repeat any code block as long as the condition is true. That is used when we sometimes don't know in advance when a simple block should terminate. So an example of for loop is that we declare a for loop. We declare the iterator variable. This iterator variable will increasingly take values that are generated by this range. Then we say that this will run in the range 1 to 10. This will first take the value 1, then in the next iteration it will take 2, then in 3, 4, up to 10, and it will print that value every time this block is run. That will let us print the values 1 to 10 using the for loop. Again, then we can use the while loop as well. We have a variable called name, which is now nothing. So we want our loop to run as long as the name is changed to something. So we use a while, and then we input a condition that name, and this is the not equal to operator. The name is not equal to something. So while the name is not equal to something, this code block will continue running. Then we ask the user to enter the name every time with every iteration, and the name is saved in the name variable using the readline method, which basically lets us read input from the console. If this name is something, then the loop terminates. If this name is not something, it's something else, then the loop continues. That was basically it for Kotlin. And now we are moving on to our Android portion. With Android, let's first talk about its state. Like, what are the stats? Why should we pick Android at all? Android is currently running on 3 billion plus Android devices, which is making it the most popular operating system in the entire world. It is most popular by a far margin. It's basically more important than Windows, Linux, iOS, and basically all the other operating systems out there. It's the largest mobile operating system in India, having a staggering share of over 96%, and is a major operating system in most of the developing countries. In US, the share is a bit marginalized between iOS and Android, but still holds a 50% share. And there are over 2.5 million apps on the Google Play Store, indicating that a large number of developers are working towards building Android apps that can be used by its 3 billion user base. Now let's talk about what are the layers of the Android operating system. So at the lowest level, Android operating system is just based on something called the Linux kernel. Linux kernel is an open source project, and it's basically a software which lets our devices talk to the user through a command line. On top of that, we have the hardware abstraction layer. So this layer allows us to use features like cameras and Wi-Fi and mobile data across a wide range of devices. Then we have the Android runtime. So we read about the JVM a while back. So Android runtime is just an implementation of the JVM, and it is responsible for running Java code. Simultaneously, we also have native libraries. So native libraries are libraries that are responsible for drawing UI, like making buttons and stuff, and they are written in C, C++. That's why they are called native. Then on top of that, we have the Android framework, and this is the layer that we'll be working on. The Android framework is completely written in Java, with newer parts being written in Kotlin. We can use Android framework to build the topmost layer of the Android operating system, which are the apps. We'll learn how to do so very soon. So let's talk about Android Studio. It is the integrated development environment that we use to build our Android apps. It is based on IntelliJ IDEA and regular releases as published by the Google Android team. It is very featured, has a lot of very handy tools that allow developers to easily build and run Android apps, and can be used by pretty much anyone using a good laptop. So there's that. Now let's look at a very simple Android application. This is a basic Android application simply named basic application. So there are some major components that we should be familiar with. One of them is the manifest. So if we look at the dictionary, a manifest is basically a description of something. So with a manifest, we declare the basic properties of our app. You can see like what type of application are we are building. It could be an instant app, it could be a normal Android app that you see on the Play Store. We can specify what icon we want, we can specify what app name we want, how many activities it has, and we'll look at activities in a bit. And this intent filter, which basically tells Android system to show our application as an app on the launcher. So when you swipe up on your home screen, you see the app's name on your device. If you don't specify this, you will never be able to launch your app directly from your launcher. Then we have the main activity. So what are activities? Activities are a component that basically represent the top level screens on an Android app. So let's say you are using WhatsApp, and WhatsApp has several screens, right? You have the main chat screen where you can see the list of your contacts. And when you click on a contact, it opens their chat. So those are two separate activities. Every screen we can represent with an activity. We'll look at the code a while later. Then we have this build.gradle file. In our build.gradle file, we specify how the compiler or the entire system should build our Android application. We can specify several IDs, a compile SDK, which basically says which Android version is our app targeting. Then we have the dependencies, which are basically libraries that other Android developers from Google and the open source community have made for us to use, so that we don't have to write that code again by ourselves. And then we have the project level build.gradle file, which contains some information like what is the version of AGP that we are using and the Kotlin version that we are using. Then let's come back to our activity main XML file. So in our activity main XML file, we can see that we have described a very simple layout. This is used to build the UI of our screen. First, we have the constraint layout, which acts as the container of this entire screen. Then we have the text view, which represents a simple text element, which you can see here. And then we have the button, which the user can click to perform some application or some operation. Now let's look at the Kotlin code. Now since the XML file only declares how the activity or the screen would look like on a device, we also have to add some interaction while building it. We can use the Android Studio emulators, test our application. In this activity, we have very simple code where we can tap on this button, and every time we tap on this button, it triggers the on-click listener that we have applied on the button. So every time this button is tapped, a count variable is included, and once it's incremented, the text view is set to the value of count. So when you tap this button like 3 times, so let's say 1, 2, 3, then the value here would be 3. This is how a main activity works, and main activity is the main basic activity of this Android app, and we can have multiple activities as the top level screens of the app. Okay, now let's look at some application fundamentals. So we just saw views which were written using XML and are used to represent UI elements like text, button, or images. Then we have the activities, which are the top level screens in our Android app. We have fragments, which are now starting to replace activities as the top level screens in our Android app. They can be nested inside activities and allow us to use the single activity architecture, which is now being heavily pushed by Google. Then we have the manifest file, which contains the information about our application, like the application icon, name, and label. Then we have finally the build or gradle file, which contains build information and dependencies of an Android application. We'll learn more about these and how to build a full-fledged app as the course moves on. That's all for today. Thanks.